Welcome and thank you for viewing my project. I'm Antonio Garza, Grantham Student ID G00058037, and I'm here to present to you my capstone project for the EE450 course of instruction. I have chosen as my project to design, develop, breadboard, and test a digital voltmeter. This is my final schematic for the project. As you can see, I've basically set up the unit into 6 sections. These are the power supply section, the range selection section, isolation amplifier, the inverting amplifier, the analog to digital converter, and the display for the output. Input power for the unit is driven by a 9-volt battery. The 9 volts is transferred to the breadboard via the second pole of the selector switch. On the primary pole of the selector switch, it goes to the selection bridge. Also right here is the back side of the input. I have closed the interface box for the remainder of this video so we can get the inputs and switch operation properly done. As you can see here, this is the input to the voltmeter. Here's the selector switch. Here it includes the off switch and the ranges, which are 2000, 200, 20, 2, and 200 millivolt. As I stated earlier, the 9 volts goes through the selector switch to operate the unit and is transferred over to the positive 5-volt power supply, which is controlled by the positive 5.1 volt zener. If you look closely here, you'll see the max microchip that controls the output for the negative 5 volts, and in this area was the 2-volt power supply, which uses a 2-volt zener to regulate the 2 volts. This area here is the input selector bridge. As you can see, each input has its own resistor, and the final adjustments for the output into the isolation amplifier can be adjusted by R12. This section right here is the isolation amplifier, and it takes the output from the selector bridge and isolates the input return from the rest of the circuit. This circuit is also adjustable with the aid of R2. This area right here is the inverting amp. It is a unity gain amp and is intended to invert the signal from the isolation amplifier to the correct polarity to match the input. This one is adjustable with the aid of R4. I failed to mention earlier that the isolation amp is also a unity gain. The output from the inverting amp goes to the input of the analog to digital converter. The output is fed to the ADC. The ADC is a 3.5 digit analog to digital converter with the 7 segment LED drivers integrated into the IC package. It is configured for the 200 millivolt scale based on the manufacturer's recommendations, and R15 in this circuit here allows for the adjustments of the 100 millivolt reference required of the ADC. This area up here are the displays for the segment LEDs with a common anode configuration. They are high output, low current LEDs and were chosen to better match the sync current capabilities of the ADC. For the first demonstration, I will set the volt calibrator for 150 millivolts. The operation of the unit is simple. The input to be tested will enter through the meter through the standard dual banana plug to the selector switch section. The 2 to 6 pole position switch provides power and signal to the meter. The selector switch is set up for the highest ranges to be encountered first to avoid damage of the lower ranges. I have set the multimeter to the 200 millivolt range. The output of the volt calibrator is 150 millivolts. And we'll zoom into the display section. I'll remove some of this light here. And you can see that the display reads 151 to 152 millivolts. It's kind of difficult to see because of the wiring. That would be eliminated once it gets put into a circuit board. For the next test, I will adjust the volt calibrator for 1.5 volts and adjust the selector switch to 2 volts. So you can see the volt calibrator is set to 1.5 volts output. I just switched the selector switch to the 2 volt position, and we'll zoom in to the digital displays, and we can see that it's representing 1.51 on the display. There's a little better representation there. For the next test, I will set the volt calibrator to 15 volts. As you can see, I've set the volt calibrator to 15 volt output. I haven't set the selector switch to the 20 volt range yet because I wanted you to see that the output is higher than the 2 volt range. At the 2 volt range, the display shows a solid one, which means it's over range. There's a zoom up of it. I'll now switch the selector switch to the 20 volt range. And our reading is 15.0501. And you can tell that the voltmeter is working. As you've seen The design is solid, the unit's functional, and the operation of the ranges tested provided only a 1.3 error in the display at the max setting, which was in the millivolt range. This meets the goal of the unit, and I'm sure the errors could be reduced once the design of the printed circuit board was complete and noise and stray capacitance mitigated and solid connections were introduced. I didn't get a chance to check the 200 and the 2000 volts because of a lack of test equipment that would read that high, but I am sure that they would be operational because of the design. I'd like to thank you for your time, and I hope that you've enjoyed my presentation. Have a great day.